Hi everyone and welcome to another video of MasterCAM. So we are going to start our new module which is MasterCAM Simulator and Code Expert. So in this module we are going to learn about MasterCAM Simulator, Simulator Overview, Verify, MasterCAM Verify and Verify Adjustments, Posting and MasterCAM Code Expert. So let's get started. So the first thing we should know about what is simulator. Simulator is a replica of actual work. Let me explain you by giving you an example. So what we are going to do is we are going to create a model in the MasterCAM and we are going to check over all the parameters before loading a program on machine. So let me tell you that we are going to create a rectangular pocket which is 200 by 100. Okay, so give some fillets. Okay, and what I'm going to do is I just want to make some stock material for this wireframe. Go to model prep, wireframe, machine, select my mill machine and stock model, all entities. Let's say that our actual size is 100 by 200. So let's say that our stock material is 120 by 220 and the thickness of the stock is 35 mm. So this is how our stock is placed on the machine. Now what we are going to do is we're gonna apply a toolpath strategy. Let me say that we're going to apply the contour strategy. Okay. Select the toolpath and select tool and mill. I'm going to select the and mill 10 mm flat end. So let's say that we have this spindle speed by default, feed rate default, plunge default, all these settings are by default. Go to cutting parameters, say that it's a ramp type cutting operation and the depth of each cut is 1 mm. As a complete revolution or complete cycle is 1 mm. Depth of cuts, lead in and lead out, yes, we need linking parameters. Go further towards minus 35. The top of the stock is 0. I'll just click OK. So what you see over here, the cutting tool path is being generated here. And what I want to do is before make this program and load this program on machine, we're gonna test this program on the software. So this is what we call the simulation. So let's simulate this tool path using the backplot setting. So we have the backplot operation. We have selected the contour operation and here the icon looks like this. So this is the simple simulation known as backplot. Click here and what we're going to see is we're going to see the play and pause button, forward backward button and the trace mode and the speed mode, and here you have the backplots and other settings. Show the tool holder option, show rapid speeds and the trace mode. So this is actually what we call the trace mode. Okay, in the tracing mode it actually shows you where the cutter moves and how much area does the cutter takes. Okay, so let's play this. So this is how it looks like. So this is what we call the simple simulation, and this simulation consists of a true strategy, and the tool. And in MasterCAM, this simulation is also known as backplot. This simulation also helps you to identify the starting point and the ending point of the entrance. The blue lines is the tool path strategy, where the cutting tool will cut down the material, and it shows you how it would look like. So this is the backplot setting. And the purpose of the simulation is to get in to know how our cutting tool actually work on real machine. If there is any accidents, the simulation will also show you where the accident is actually done and how it occurs and where it occurs. So hopefully you understand how the simulation works. Stay tuned for more videos. Thank you very much. Hi everyone, I hope you are fine and welcome to another video of MasterCAM. So we have started the module number 6, which is all about the MasterCAM simulator and code experts. So we just discussed about the MasterCAM simulator, how it actually looks like and what is simulator actually. So today we're going to discuss the simulator overview and MasterCAM verify and some verify adjustments, posting and MasterCAM code experts. So let's get started. So in the last video, we just know how the simulation actually worked like and how the the cutting tool path look like. So here we're going to know how many types of simulation we have. So first thing, we know about the backplot. So in actually backplot, we have a simple type of simulation where there is no cutting tool, so there is no such type of cutting material is happening. Okay, so just the cutting tool and the tool path strategy. Now the next setting is the verify mode. In the verify mode, another window is open, which is known as MasterCAM simulator. And here you will see that your stock, your tool holder, and some other options here. Here you will see that your cutting tool moves, machine type or machine axis, the movement type, the operation, which is the contour operation, and the strategy we use applying is the ramp type. Your tool number ID, tool orientation, tool tip position, and the axis. Total feed length, feed time, rapid length, rapid time, and total length. Also shows the maximum x-axis, y-axis, and z-axis distance. And some other settings like the coolant is on or off, either you have applied the compensation, either what feed rate you have applied, and the spindle speed ratio. So let's play it. Here we have the performance and the precision, play and forward and backward, and speed setting. So let's play this. So in the verify mode, what you see over here is that the cutting tool is removing that material, and it will show you how it actually looked like. So this is how the cutting tool will operate on this workpiece and remove that material. In actually, the tool operations will work like that. So this is what we call the verify mode. So we have three modes. One is called the backplot, which is also known as simple simulation. There is no cutting material, simulation is done. The next mode is the verify mode. In the verify mode, the tool will cut down your material and show you how it looks like after the cutting. And in the third operation, which is called the simulation, and in this simulation, it will show you how actually your machine look like and how the machine will cut your material. So this is how you can see this. Actually, the machine is a 5-axis machine, as so you see it here. So let me go back and select machine type. So you can select your machine by clicking on this setting, this symbol, when you show up these simulator options here, and you can just stop your setup here, okay, and also the fixture setup here, okay. Go to data, you can apply the cutter compensation control, tolerance, all these settings. So we have the 5-axis machine. You can select it 3-axis, or you can select any of them, okay, depending upon which machine you have, okay. So just selected the 3-axis machine. And here we have the positions in X, Y, and Z direction. Go to simulation. And this is how the machine will look like, okay. So right now we have the 3-axis machine, and the cutting tool is hold down on this side. Let me go and change some settings again. Simulation. Let's see that 35. Okay. Click on simulation. And our workpiece is located on the top of side. Okay. Let's say that we can again change the settings. Go to simulation, make it 40 millimeters. Well, okay. Simulation. And here we have the workpiece on the table. Now, what I'm going to do is I'm going to show you how it looked like on a real machine. So let's say that we have slowed down our machine, process, click on play. And here it will look like. The table is moving in X and Y direction, and in Z direction, the head is moving. So this machine, we have 2 motions on the bed and 1 motion on the head, which is the actual motion. And actually, it would look like that on your real machine. So simulation helps you to identify your current workpiece positions, tool path strategy, tool changing position, fixturing positions, all these things. And also tells you that if you have any collision between your tool and table, and workpiece, tool, table, all these things, it will identify you that your tool will be collide with your workpiece or the stock or the fixtures or the table. So this is what we have: the visibility, tool path visibility, initial stock visibility. So was the initial stock. So just hide down or make it transparent, and this is just enable or disable your workpiece initial stock. You can either hide the machine transparency or machine housing. This is transparent, or you can completely hide your machine. Okay. So this is how it actually works. Your current operation, all operation, segments, trace, both, follow. You can check it. Go to view. You have multiple views here. You can select either the top view. You can select either the right view or the front view. Or you can either select your isometric view. And here we have the single view, two view, column view, and four view. Restore to default position, or we can say that single view. So here we have the report option, move option, axis control option, which axis is being moving and in which direction, machine settings, compare the data, all these things. So if you have a multiple operations, like we are if you have contour operation, pocket operation, and drilling operation, you may select all these operations once and then click on the back plot. Either we want to check the back plot, verify mode, or simulate view. All operations will be shown by clicking on the selected simulation option. Either you want to check the back plot, either we want to check the verify or simulate option. Okay. So this is how we can do simulation on MasterCAM using the MasterCAM simulator. Hopefully you understand all these things. Let's get know more interesting things in the MasterCAM simulator. Stay tuned for more videos. Thank you very much. Hi everyone, I hope you are fine. Welcome to another video of MasterCAM. So we have already started the module number 6, which is all about the MasterCAM simulator and code expert. So in the previous video, we just discussed about what is MasterCAM simulator and how simulator works. So today video, we are going to learn about MasterCAM verify and verify adjustments, posting, and MasterCAM code expert. So let's get started. So I have already make a model in the MasterCAM. We're using the MasterCAM 2023 version. If you have a MasterCAM 2023 or the later version, so it's same. The GUI is totally same. You don't need to worry about the graphical user interface of 2023 or 2024, or especially if you have a older version which is 2022, so don't worry about it. So here what you see that we have a rectangular block, and in the rectangular block we have a rectangular pocket inside. So what I'm going to tell you that the total length of this block is 200 by 100 by 50 millimeter. So the length is 200, width is 100, and the thickness is 50 millimeters. So we're using the metric system for dimensioning all these things. Okay. And for the pocket size, we have 100 by 50 by 25 millimeter. So we can say that the 25 millimeter is the depth of this pocket, 100 millimeter is the length of this pocket, and 15 millimeter is the width of this pocket. So what we are going to do is we're going to test the simulator using MasterCAM Verify, how it works, and verify adjustments. So the purpose of verify adjustments is to get to know how much amount of our cutting tool will get into our workpiece and cut down the material. Some of the cutting tools have different specifications. Let me show you. So just going to apply the pocket here. So let me show you. Go to milling toolpath or go to toolpath. We're going to apply the 3D pocketing here. So go to 3D pocket, select all these sides and selection. Yes, we have the containment. Select the containment, or we can say that the boundary. Click OK and OK. So here what you see that, let me go and add it. So what you see that there is a tool which is known as the end mill tool, and here we have to define the tool geometry. So what you see over here is the cutting diameter, which is 10 millimeter. I'm going to use a 10 millimeter dia and mill, and its whole dia is 10 millimeter. So overall length is 72 millimeter, which means that 50 millimeter is the thickness of the block, and it will come, we have a large amount of length, which is 72 millimeter. So we can do this by this tool. If you have a shorten the length, the cutting tool will collide with this and not able to cut down this part. Okay. So make sure that you have a length of tool, what operation you are going to perform. Okay. And the main thing is cutting length. So what you see over here, the fluted area, the yellow area represents the fluted area where we have the cutting. Okay. So this length is 16 millimeter. What you see over here, we have a pocket here, and its thickness is 25 millimeter indeed. But the cutting length is 16 millimeter. So how it can be done? So you can see that this length is not enough to cut down this. So you have to select the appropriate tool for your operation. If you have cutting fluted length is smaller, and you have a pocket or depth of cuts or depth where the cutting tool reach and able to cut down that material is very deep, the cutter will be suddenly break down, or it will damage your workpiece. So make sure you have to set your cutting tool properly, or recommended tools you have to select it. So the non-cutting geometry area is, we have the shoulder length of 32 millimeters. Okay. And the shoulder diameter is 9.5. Okay. This means that the 32 millimeter is the length where the cutting tool dia is 9.5. Okay. So we have the dia 10 millimeter, the cutting area, and the non-cutting area diameter is 9.5, which means it's under safe point. Okay. And the total shoulder length is 32 millimeter. And the shank dia is 10 millimeter. This shank dia represents that the cutting tool will be hold down in the holder on this area. Okay. So this is the geometry of the cutting tool. So the next thing is, you have to define the tool number. So this is my tool number 1. So I can define it that this is tool number 1. And you are going to apply the length offset, then you have to set the length offset. For example, I'm going to apply the length offset of H1 or F1, then simply define that this tool is H1. And the diameter offset is 1. Definitely the tool number is 1. We have the by default setting at 1. length offset and diameter offset 1. So head is 0. And how about the cutting speed is 338. This is the default cutting speed set by the MasterCAM. So you need to calculate your cutting speed for this operation. So let me define that we are going to cut this material with a cutting speed of 1500 millimeters per minute. And the feet per tooth is cutting according to the calculation is 0.0709 millimeters. Number of newton we are going to use is 4. And if you want to calculate it, you can automatically calculate it by clicking on this. Okay, so it will recalculate your cutting speed accordingly. So let me say that I'm going to cut this material at 1500 millimeters per minute. Feet per tooth is 0.1, newton is this, and the feed rate is, we have a feed rate of 19,000. It's a so high cutting feed rate. So let me say that feed rate we're going to set is 500, blunt rate is 100, and the retract feed is 2000. It is by default set by the machine. And spindle RPM we have is 20,000. So spindle direction is clockwise. We're going to use the carbide, and the name of the tool is 10 millimeter. By using this roughing tool and finishing tool, we have to define the step over all these things later. So just finish it. And now the most important thing, we need to verify our tool. Okay, so just right click and edit projection. So here what you see our tool projections. Let me say that I want to put this on this top of this and place it at this corner. Click here. And now you can adjust your cutting tool length and how much amount of tool will be hold down inside this holder. Okay. So this is how you can define it. If you go make it down, you see that the holder will be clamped or hold on this tool, and it will definitely collide with this part. So make sure you have to verify your tool before put the tool into holder and go on operation machine. So this is what we call the verification. So let's enter this, press enter to accept changes, and let's move to other. So the surface parameter we have, this is the clearance, which is set to be 50 millimeter. Let's uncheck. Retract point is 25. Okay. And the feed plane is 5 millimeter. So we have a part on the top plane, which is 0 point, and the feed plane is 5 millimeter above this part. So let me set this absolute 5 millimeter. How about the compensation? So we are going to apply the compensation inside this containment boundary. So let's select the inside. How about the roughing parameters? So you need to set the roughing parameters for the operation. We're going to set the cutting tool will cut down the material at each step 1.0 millimeter. And the cutting depth will be incremental method. Okay. The gap setting should be set as correct, broken, smooth, or follow surface. So we set it smooth, motion, gap, keep tool down. And the tool operation will be optimize cut order. Click OK. Go to pocket parameters, and you have to select the cutting method. Either you are going to apply the zigzag, constant, overlap spiral, parallel spiral, or parallel spiral with green corners. So you need to set the appropriate cutting method for this operation, just like doing in 2D operation. So I just like to use the parallel spiral operation. We have to set the percentage over step or step over. So we define that we have the cutting tool of 10 millimeter dia. We use the 7.5 millimeter each. Just click OK. So here we have the pocket operation. So let's check it. Go to backplot setting and check your tool. So this is how it operates. This shows that our cutting tool will not collide with the workpiece on any fixture. Okay? There is no such errors. Click OK. And now what we are going to do is we are going to apply the contour operation on the outside. We're going to apply the surface rough operation using the contour operation, or you can do it by using the 2D operation, just like here we have the contour operation. So click on the chain, click OK, and you need to define the cutting tool. So we have the 10 millimeter end mill, and we have to set the cutting speed, all these things here. Go to cutting parameters. We have the cutting parameters of ramp cutting. Set the ramp cut of 1.5. Lead in and lead out is tangential. Linking parameters is absolute, and make it minus 50 millimeter. The fit plane is 2 millimeter absolute. Click OK. So here we have the tool path. But you see, the tool path goes inside. It means that you need to change the side. So go to geometry, click on the chain, right click and change the side. So after changing the side, you will see here the arrow is going outside in outward direction. This means that the side has been changed. So let me show you again. Change side, it goes inside. It means the chain tool path will be work inside. And if you're going to change this side, it will work on the outside. Click OK. Refresh it or regenerate all the operations, selected operations. It will make like this. So this is how we can generate the tool path and check our tool collisions. I can also say that we can check the gauges. So let's verify all these operations. Go to machine and verify. So this is how we can do the operations. We can verify all the gauges. So I hope you understand how we can check our tool collision and gauges using the tool verification and MasterCAM verify adjustments. So thank you very much. Stay tuned for more videos. Hi everyone, I hope you are fine and welcome to another video of MasterCAM. So we have already started the module number 6, which is all about the MasterCAM simulator and code expert. So in the previous videos, we have discussed about the MasterCAM simulator and simulator overview. And we did in the last video of MasterCAM verify and verify adjustments. We're going to check the tool gauges and the tool breakage, how much amount of tool is going to be cut down the material using the verify adjustments. So in today's video, we are going to do some posting work and MasterCAM code expert. So let's get started. So we have already the model loaded, and we have applied the toolbars. So we have two toolbars. One is the surface rough pocket. We have the pocket here, and we have the contour. We can say that 2D contouring operation outside. And what we are going to do is we are going to apply the posting. So first thing first, make sure that you need to know about your machine. For example, I'm going to give you an example that we have Android mobiles. But the manufacturer of Android mobiles are different. Like we have the Samsung mobile and Google mobile. We have the Motorola mobile, and Nokia has also the Android. But the system which is being installed in all these mobiles is called the Android. And we have the different version of Android. For example, we have the Android of 10.0. We have different versions like Oreo. We have Jelly Bean. All these are called the versions. Or you can define it by using the 10.0 version, 11.0 or 12.0, which is known as, I think, Pie, Android Pie. So same as in the Android mobiles or Android versions, we have different types of CNC machines and different controllers. So for that different controllers and different machines, you need to know about their specifications and which file is going to be run. Okay? So if you have a generic controller, like I'm going to tell you that if you have a GSK controller, which is a Chinese-made controller, and a Chinese-made company which made GSK controller, or if you have a Shenzhen controller, which is also a Chinese company, most probably they can read the generic CNC files or CNC programs. So we loaded, let me show you, we loaded a default machine here, or you can manage list. Okay. So here what you see that we have default MasterCAM machine in a millimeter and inch system. Okay. So if you have a machine and you have a machine file, you can load it machine file into MasterCAM. But by default, you have a machine here is called the default or generic. And for generic machining operations, you have generic post-process. A post-process which translate all these toolpath data into codes. Or you can say that the computer will translate all these instructions into machine-readable data. This process is called posting. So what I'm going to do is we have two operations here. One is called the roughing pocket operation and the other operation is called the contour. What I'm going to do is I'm gonna make a post of these two instructions according to my machine readable data. So just click on the G1. This represents code. Or you can go to machine and we have a post tab here. Click on generate. So one thing you should notice that I have selected all the toolbars. If you want to select a certain, just click on each certain toolpath and it will create a G code. Okay. So let me select all this. Group 1. Click generate, and it is going to be convert your instructions into machine readable data. Okay, so you have to select the ANSI file. It will ask you if it is need to be overwrite. Just click on overwrite. You want to edit the file? Yes, you want to edit the file, and the which extension you want to need. So if you want to need NC file, which is known as numerical control, most of the controllers read the NC file. Some of the controllers read CNC file. And some of the controllers read .txt. So you need to define which file you want. So I'm going to use these .nc file. Click OK. So here what you see that the instruction files, the machine we have selected is default, and for default machine, the selected post is default FANUC post. Click OK. And it's going to save that file. So MasterCAM verified.nc is the file name. I'm going to save this on desktop. Click OK or save. So this is going to be processed and make a G code file or machine readable data. So this machine readable data is going to be open in the MasterCAM Code Expert, an independent software which is installed with the MasterCAM. So the purpose of MasterCAM Code Expert is to read down the NC file or machine instruction file. You're going to see the name of the file, which is MasterCAM Verified, and the extension, which is known as the numerical control instructions. And here, what you see, different colors codes are being shown here. Okay. So some of them written in a black color, some of in red color, in dark blue or navy blue, in light sky blue, in brown color. So you see all these things. So these all are called the instructions. These instructions going to be read by the machine and make your model according it. So what we're going to do is, if I'm going to change anything, you're going to see what happens. For example, I'm going to remove this line or remove this instruction. So to show that in yellow. This means that the file is added but not saved. If you save this file, it's going to convert it into green. So this means that this block is going to be added or this block is being edited. Okay. So whatever it shows the date and the time of the instructions being modified or the file is created, name of the file, where it is saved, the material specification, the tool specification, all these instructions are going to be shown here. So this is what we call the MasterCAM Code Expert. Here are some tabs you need to know about this. In the file, you just go and make save, option, print, and help. In the home tab, you can just copy, paste, or see, find and replace, multi-stream, or NC configuration. You can change the NC configuration. Okay. Call out comments. You want to add the comments. If the utilities, I'm going to add some utilities here, different axes with the semicolons, X, Y, Z, A, B, C, S, and F. Block numberings, fonts, and colors. And you select the different controllers like FANUC Mill, FANUC Lathe Series, FANUC Router, or generic multi-stream, Haas Mill. So these are the different controllers and machines. Okay. So we're going to use the FANUC Mill by default. In the View tab, you can just load in tilted vertical position or horizontal position, say workplace, zoom in or zoom out. You're going to zoom in by control and roll down your scroll to zoom in and zoom out. In the NC function tab, you're going to synchronize your things. If you have 2 or more tools and you want to move towards another tool, just go and select the next. Next. So if you have a multi-stream display, you're going to see the multi-stream display. If you want to add blocks here or remove blocks, so this will show you that these are the blocks. You want to add blocks, you can insert the block. This is how we can say that it's a block. Or if you want to remove blocks, you can just click on the block numbers to delete. It's so simple. And if you want to search anything, just go home and search that thing. For example, I'm going to search the H1. We're going to search all H1 in the program. This one is H1 and this one is H1. And if you want to replace these things, you can just go and replace this, just like a normal editor. So this is what we call the code expert. What you're going to do is now, you're going to save this file. I just saved this file. And I'm going to load this file in my USB and then transfer to the machine. These instructions will be loaded into the machine. And after loaded into the machine, we can run these instructions in machine. And machine will follow all these instructions and make a part according to this instruction. So hopefully you understand how the MasterCAM Code Expert works and how it will be helpful to edit your G codes. So for now, this is done. Hopefully you understand all these things. For more videos, stay tuned. Thank you very much. Hi everyone, I hope you are fine and welcome to MasterCAM. So we have completed our module number 6, which is all about the MasterCAM Simulator and Code Expert. What we have learned in this module is Introduction to MasterCAM Simulator. We covered the MasterCAM Simulator overview, MasterCAM verify adjustments, we did the posting, and we learned about MasterCAM Code Expert. Now it's time to check your knowledge. So we have some multiple choice questions. What you have to do is you have to pick the right answer to question. So let's get started. Which of the following statements about MasterCAM Simulator is true? Option A, it can only simulate milling operation. Option B, it cannot simulate turning operations. Option C, it provides a virtual environment to preview and verify machining processes. Option D, it requires an additional license separate from MasterCAM. So the right answer to the question is option C. It provides a virtual environment to preview and verify machining processes. The next question is, in MasterCAM Simulator, what is the purpose of backplot feature? Option A, to undo the last machining operation. Option B, to visualize the tool path motion in reverse. Option C, to simulate tool collisions. Option D, to export simulation results as a video file. So the right answer to the question is option B, to visualize the toolpath motion in reverse. The next question is, what is the purpose of MasterCAM Code Expert 2023? Option A, to design 3D models. Option B, to generate G-code for CNC machining. Option C, to simulate machining toolpaths. Option D, to recreate engineering drawings. So the right answer to the question is option B, to generate G-code for CNC machining. The next question is, which file format does MasterCAM Code Expert 2023 typically output? Option A, DWG. Option B, STL. Option C, GCD. Option D, NC. So the right answer to the question is option D, NC. The NC stands for numerical control. The next question is, what is the primary purpose of MasterCAM posting 2023? Option A, to create 3D models. Option B, to generate toolpaths. Option C, to simulate machining operations. Option D, to output CNC machine code. So the right answer to the question is option D, to output CNC machine code. The next question is, what role does MasterCAM posting 2023 play in the CNC machining workflow? Option A, designing 3D models x-axis. Option B, generating toolpaths. Option C, setting up machine parameters. Option D, converting toolpaths to machine instructions. So the right answer to the question is option D, converting toolpaths to machine instructions. So hopefully you got your answers right. So thank you very much.